Hi guys, this is the Innovative Minds tutor. In this video, we are going to work with drawing a cubic function, right? Sketch the graph of f of x is equals to x cubed plus x squared minus x cubed minus 10, showing all the stationary points and the intercept with the axis, right? So when you're drawing a cubic function, guys, there are things that you need to take note of. Let's take note of stationary points. Take note of stationary points. Okay, this is the first part. First thing first, let's find the stationary points. How do we find the first stationary points? How do we find the stationary points? It's a first derivative. So you first derive and you remember first derivative and equate to 0. So we need to derive this given cubic equation. So when we are deriving x cube will result us to have 3x squared using a power rule, right? We use a power rule to get 3 squared. Remember that it's 1 times 3, then you subtract the power by 1, so we get 3x squared. Similarly, with x squared, we are going to get 2x because it's 1 times 2, which is 2, and subtract the power by 1, then we're left with 2x. Negative 1 times 1, that will be negative 1. And 1 minus 1, that will be 0. X to the power 0, it's 1. So then we are going to have negative 1. In this case, what is the derivative of a constant? That's 0. So we want to put 0 there. So now when we are here, we need to find the x value of a stationary point. Remember what I told you, that it's a first derivative and equate to 0. So where there is f of x, you replace by 0 there. So it's going to be 3x squared plus 2x minus 1. So from here, we can factorize this. So the factors of 3x squared is 3x and x. So the factors of 1 is 1 and 1. So they do satisfy this. If you want to check whether they satisfy, is to multiply back out. So is to multiply back, then you will see that it will give you the same equation. So the sign, since the last sign is negative here, so that means they will have different sign. It's going to be negative here and it's going to be positive here. So equating to 0, we get 3x minus 1 is equals to 1 there, and we have x plus 1 equated to 0 there. Divide everything by 0 here. By 3, sorry for that. I was supposed to equate to 0, so but it's fine. We are going to have negative 1 in this case. And hence here we're having 1 is equals to 3 and negative 1. So we are not done. The stationary points, it's a coordinate. So it's an ordered pair. So we should have 1 over 3 as an x-intercept. And we have negative 1 here. What is missing now are the y values. How do we find the y values? We find the y values by substituting the x values back to the original graphs. So let's take our calculator where there is a where we see x, we are going to replace it by so what are you going to do? You're going to say 1 over, just say 1 divided by 3 cube, okay, plus, let's place 1 over 3 squared minus 1 over 3, right? Then minus 10, what are we going to get? We are getting negative 275 divided by 27. So it's going to be negative 275 divided by 27. So negative 227, negative 275 divided by 27. So let's now take negative 1, place it there, right? Put negative 1 in your calculator there. What are you going to get? So let's see. If you place negative 1, where there is x to the original, we are going to place negative 1. Okay, we get negative 1. will result to -9. So our solution will be -9. So definitely we are going to have -9 as our solution. Yeah. Okay. That was the stationary points. Hope the stationary points, remember, they are our turning points. Now let's test for the shape so that we know how will our shape look like, right? By the look of things, when you look at those coordinates, you could see that our local maximum is found on -1 and 9, and this is a local minimum, right? Another part is that when you look at our a value there, the first coefficient of this will determine the shape. So if it's positive, that means a is greater than 0, so it will start at maximum and goes to minimum. So we are going to have a shape like this. So this is the shape that we are going to have, right? Then the third thing that you need to look at, it's the intercepts when sketching a cubic function, right? So to make life easier, remember that for x-intercept, you let y be equal to 0. Okay, let's, to get the x-intercept, remember that there's a method that we are using. In our previous video, we learned about synthetic. So let's try the possible values. If you place -1, then we saw that if you place 1, start by checking the possible factors there. When we place 1 cube plus 1 squared minus 1 minus 10, what are we getting? We are getting -9. But if we place -1, we're getting -11. We're getting -11. So, well, we need to be careful. Let's think about other factors. Let's think of about other factors. Let's try 2 now. When we try 2 cube plus 2 squared minus 2 minus 10, we get 0. So that means 2 is the factor in this case. So what are we going to do? We are going to say x minus 2 is a factor. Okay, so we are going to use a synthetic division. It's the shortest way of solving for this cubic, it's the shortest way of solving a cubic function. So let's go back and take the coefficient of x cubed, that's going to be 1. Coefficient of x squared, that's going to be 1. Coefficient of the third term there, that's going to be -1, and the constant, that's going to be 10. The possible factor that we chose is 2. Then you are going to drop the first coefficient, which of 1, so it's going to be 1 here. Then the coefficient will multiply the possible factor. 1 times 2, that's going to be 2. 2 plus 1, that's going to be 3. Then 3 times 2, that's going to be 6. 6 plus -1, we get positive 5. Sorry for that. 5 times 2, that's positive 10. Positive 10 plus -10, we get 0. So this is what we are having, guys. So remember that we have a factor there, which is x minus 2. So this forms a trinomial. So this will be x squared. The second term will be 3x. The coefficient, the constant will be 5, equated to 0. So when you equate everything to 0 here, we get 2. But we cannot factorize this. Why? Because look at the last term, it's 5. The factors of 5 doesn't give us 3. So we can use a quadratic formula. So in this case, let's try a quadratic. X is equals to -b plus or minus b squared minus 4ac divided by 2a. So let's try to where there is b be placed 3. So it's going to be -3 plus, let's place 3 squared minus a, it's going to be 1. C, it's going to be 5 divided by 2 times 1. So let's continue from here. We have -3 plus or minus. Let's punch this. 3 squared 3 squared is 9, and we have negative 4 times 1, that will be negative 4 times 5, that's 20. 9 minus 20, we are going to get negative 11. 2 times 1, that's going to be 2. So we cannot have a square root of a negative number, so that means these x values are not applicable. So meaning that our value that we're having, it's x as 2, right? So that's going to be the x-intercept. So let's place our values so we can sketch now. We can see that our value, x value, is 2 there, 2 and 0, the coordinates. And don't forget that this is y-axis and this is x-axis. So what about our stationary point? Remember, the first stationary point, it's a local maximum, which is negative 1 and 9. So it's going to be 0, 1, negative 1 here. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are going to have somewhere here, we are going to have negative 1 and negative 9. Okay, so we also have to find the y-intercept. Remember that we left the y-intercept here. To find the y-intercept, let y-intercept, let x be 0, meaning that where we place 0, 0 cube is 0, 0 squared plus 0, it's going to be, and place 0, that's going to be minus 10. So it's 0 and minus 10. So 0 and minus 10, that will be somewhere here. So which is going to be 0 and minus 10. So in other words, we are going to have this is going to be our local max, and it will pass here, it will pass here. Okay, sorry for that. So, and it goes here. All right, so this is how our shape will be, but we let's not forget placing 1 over 3. 1 over 3 is the same as 1 over 3, it's the same as 0, 3. So it's somewhere here, 0, 3 and negative 10, because this gives negative 275 divided by 27, it's the same as negative 10. So meaning that it will be here, it will be a local what we call this, a local, sorry for this here, this part. So this is 0, negative 10, and this will be 1 over 3. So 1 over 3 as well as negative 275 divided by 27. Just as this, we predicted that we are going to have a local maximum and a local minimum in this case, since a is greater than 0. So this is how your shape will be. Yeah, that's how we should do it, guys. Apply the principles. You only need 3 things, guys: stationary points, shape, as well as intercepts. So when you've done that, remember, in some cases they will ask you a point of inflection. A point of inflection will always be the second derivative. You derive twice, then you'll place the point of inflection where it should be placed. So hope you find this video useful, guys. Let's keep growing. Next week we are focusing on graph interpretation of calculus. Let's share the videos. Let's grow. Let's subscribe. Let's grow this channel. We are on our road to 1K, but now we're at 350. It is possible because we believe on positivity and positivity. And remember, we wish you all the best and we love you.